Have you got it?
Yes, sir.
So that is the book which we will be uh, basically following for this midterm, especially up to midterm. Most of the content, because after midterm we will follow or we will go for the other portion. But before midterm, we will be just going through this book only. Okay. So let me just share the same book. As I told, I will be going through that book only, so you can see my screen. This is chapter 4 of that particular book. And this is in fact the PDF version, and that what I have opened is CHM format. If you want, I can give you movie format also, which you can see in your Kindle books. So if any one of you prefer to read, go through this sort of books through Kindle, I can share that one also. So do you want that Kindle version also? Okay, so this is the chapter. It will go, I think this is page number 99. Let me go through just that's the same book in a different format, CHM format. So last day, I think last two classes in lab and in theory, we talked about how to acquire data. So data acquisitions we have talked about this sort of discussion we had how to acquire data, and then we talked about what are the different acquisition tools, so DD etc. we can use. Okay, so today I will be just going through this volume analysis. Now volume analysis is the volume is something which all of you know. Hmm? Can anyone tell what is a volume? बोलो सब लोग जानते हो यार, ऐसा नहीं है.
Similar
क्या
to
होता है
partition. Similar to partitions that we have in our computers.
Okay, so as you can see here, a volume is a collection of addressable sectors that an operating system or application can use for data storage. If you define a volume can be defined as a collection of addressable sectors, that an OS or an application can use for data storage. The sectors in a volume need not be consecutive on physical storage devices. Instead, they need to give the impression that they are. Okay, so normally one hard disk is one volume, but sometimes we can have one hard disk and we can partition it, or we can basically divide it into several volumes, like what we see in Windows. Like if you just see my system, then you can see a volume called CF. There is a, I think this is visible.
Yes, sir.
So say this is one volume, volume C. This is another volume D. This is another volume, say Google Drive, and this is another volume for DVD drive. Now, in my case, this volume C is separate hard disk and volume D is a separate hard disk. Volume C is a separate hard disk. Volume D D is a separate hard disk in my case. But in several cases, you know that one single hard disk can be partitioned into several volumes. Here, this is a separate volume, no doubt. Again, this is another device. So this is one device, this is one device, this is one device. This, in fact, is a logical one only. So there is no device as such where this volume exists. In fact, this is a Google file system, and this only exists logically. And the data which is there, which has to be used, is mounted in C drive only. Okay, so this volume can be, so as we were talking about, so this volume normally, say the central concept of volume is one is to assemble multiple storage volumes into large volume. Now, on the other hand, we can have scenario. I think you remember last time when you were physical, and I was just showing you that in HP lab, the server part of HP lab, if you can recall, there I had just shown you that there are 10 hard disks kept one after another, and we view them as a single volume. Okay, if you can recall that in one of the boxes, one of the chassis, in fact, one of the what is called as that cabinet, we had 10 hard disks kept one after another, giving total 10 terabyte of space, and then they were mounted as a single volume. So one is to assemble multiple storage volumes into one storage volume, or multiple storage devices, physical devices, into one logical storage volume, and the other one is to partition storage volumes into an independent partitions. And two folds, the volume works as a two-fold concept. One is we have a bigger hard disk and we want to partition them. So for personal computers, we want to partition them, give them a logical, in fact, a view that they are independent. The other one is we have so many drives or so many hard disks, and we want to make them, they said that make them in such a way that they should look as a single unit. So for these two cases, we use this volume. People also use the term partition instead of volume in certain cases. So, general theory of partitions, if you say. So, partition is a collection of consecutive sectors in a volume. Now, you can see here, as I told in my system. So, if you see, there are there is no partition into my hard disk as such. This is, as I told, this is one hard disk. This is another hard disk. This is another device. In fact, there is nothing, but if some CD is inserted, so this will have another drive, and this is logical. So this is a logical volume, and that's why it told that if you look into the definition, that volume appears to be consecutive, but they only need to give the impression that they are consecutive on a physical storage, but they are not needed to be. Like here, this volume, the Google Drive G, this volume in fact is only logical, and hence it is taking some space from this drive only. You can see here drive. So in this in Google Drive, I think I go to user, it was an IT, and then you can see here Google Drive, and so this is one volume. This whole space is taken up here. So this doesn't have any physical space, and that's where the partition and the volume differs. So one of the concept in a volume system is to create partition. A partition is a collection of consecutive sectors in a volume. By definition, a partition is also a volume, which is why the terms are frequently confused. So a volume in which a partition is located is the partition's parent volume. So in this book, they have referred that a volume in which a partition is located as a partition's parent volume. So you can see in this case, like C is a parent volume for G drive. So partitions are used in many scenarios, like some file systems have a maximum size that is smaller than hard disk. Many laptops use a special partition to store memory content when the system is put to sleep, like that hibernation. So when we say my system is hibernated, or we want to hibernate basically the laptops. So when we hibernate the laptops from your operating system concepts, that the idea should immediately come to your mind that when the system is basically going to hibernate in a long sleep, then the total status of the system has to be maintained. That means which files were opened, which site was opened, which music was playing, so what were the processes running the system, and so on. So all these informations has to be kept somewhere. And obviously, this cannot be kept in RAM, isn't it? Because if you kept it in a RAM, then as soon as it will go down, it will go into sleep mode. Probably the content of RAM will be vanished if the RAM is not taking constant power to refresh it. And if it takes constant power to refresh it, then probably there is no savings in the power, and that's one of the main reason of hibernation. Am I clear? Mr.
Yes,
Prince,
sir.
सुन रहे हो?
सर
हो इधर ही?
यस सर, इधर ही है सर।
हाइबरनेशन देखे हो सिस्टम में?
यस सर।
क्या होता है हाइबरनेशन में?
सिस्टम स्लीप मोड में सर चला जाता है।
स्लीप मोड में चला जाता है। तो स्लीप मोड में जाने के लिए क्या क्या चाहिए सिस्टम को?
स्लीप मोड में जाने के लिए सर, ऐसे तो सर नॉर्मली हम लोगों को सर ऑप्शन से आ जाता है।
ऑप्शन से आ जाता है? अरे भाई, स्लीप मोड में अगर कोई चीज जाएगा तो वंस दैट विल अगेन कम अप, वेक अप। तो स्लीप मोड में जाने के लिए सच कुछ नहीं चाहिए, बट जगने के लिए उसको वंस इट विल वेक अप, it needs the information ki what was the scenario, isn't it?
Yes sir, last time.
So that's why in many laptops a special partition is used to store that memory content. When it will go to sleep mode, or everything, the whole state of the laptop will be kept into that memory. So that's why you need a separate partition, and those partitions are normally not visible to human being. Yes, Abhishek, bolo.
सर वो जो स्वैप एरिया हमें दिखाता है वो उसी पर्पस के लिए यूज होता है या फिर वो किसी और पर्पस के लिए यूज होता है?
स्वैप एरिया जो यूज होता है वो तुम्हारा वर्चुअल मेमोरी के लिए यूज होता है।
ओके सर, वर्चुअल रैम एक तरीके से बोल सकते हैं।
वर्चुअल रैम जो होता है ना, वर्चुअल मेमोरी पढ़े हो ना ऑपरेटिंग सिस्टम में?
यस सर, यस सर।
वहां हम पढ़ते हैं क्या कि रैम जितना दिखता है उससे ज्यादा रैम भी हम यूज कर सकते हैं।
यस सर।
वर्चुअल मेमोरी का कॉन्सेप्ट क्या है कि अगर फिजिकल एड्रेस मेरा 10 बिट का है तो आई कैन यूज अ लॉजिकल एड्रेस ऑफ से 12 और 14 बिट्स आल्सो।
यस सर।
तो अगर हम 14 बिट्स का लॉजिकल एड्रेस यूज करें तो बाकी जो मेमोरी है वो तो रैम में है नहीं।
यस सर।
जो हम पेजिंग या ये करते हैं ना, डिमांड पेजिंग स्पेशली,
यस सर।
तो वो कहाँ से आता है? तो हम वहाँ पढ़े थे ना, वहाँ की हार्ड डिस्क से हम डेटा लेके आते हैं, सर्च करते हैं हार्ड डिस्क में और वहाँ से लेके आते हैं।
यस सर, तो वही वाला
तो वो
स्वैप
हार्ड
एरिया
डिस्क,
होता है।
वो एक हार्ड डिस्क का स्पेशल एरिया होता है जो स्वैप स्पेस होता है।
ओके सर।
इसलिए नॉर्मली स्वैप स्पेस को जब भी हम इंस्टॉल करते हैं सिस्टम, तो विंडोज तो ऑटोमेटिक, इवन विंडोज में भी ऑप्शन है, यू कैन चेंज इट फ्रॉम एनवायरमेंटल वेरिएबल। in Linux they ask for it. So normal the rule of thumb is ki you give you make your swap space double the space of RAM.
ओके।
Okay, so swap
Okay.
space is a different thing.
ओके, थैंक यू सर।
It is a different one. Swap space, thank you for this course and for others also. Swap space is a different area, and this is normally a different area, and which is in fact not visible to us. Most of the time, even if you list, if you are listing with means a very low say high level disk drives, so you may not see it. Say like if I go to, say this is the Windows system, and if I go to say disk.
Yes sir, in Windows generally we don't see it, but in case of Linux then there is our options of swap area while installing some Linux system.
Yes. So say like you see this, the disks and volume in my system, in this system only. You say, as I was telling, that this is one of the drive which was C drive in my system. Okay, and this is another drive, disk 0. So disk 0 is an SSD, and this is having just 238. So now you see here, and you can compare these two. So this is C drive, SRC, and you can see the capacity is. I think दिखाता है ना, किस व्यू में आता है? Details. Say. You can see 237 GB, which is obviously this SATA disk.
Yes.
Then we have data D, which is this Western Digital disk, right? This number. This is
Yes.
D, and then this has got an NTFS partition. NTFS disk. Now you see this one itself has so many partitions. So total disk was 238 GB. There is one partition of 100 MB, which is FAT32. Then there is another partition of 237 GB, which is an NTFS partition. Then there is another partition of 1 GB, which is again an NTFS partition, but this is called as a recovery, and this is normally system generated partitions. Normally user generates or user interested is generating this partition only. These two partitions are kept or generated automatically. And you might have seen that in newer disks, there are by default some partitions which are being created with very small sizes.
Yes, sir.
Here you see there is nothing else because this is not bootable. So it's just a complete whatever was the total capacity, this total capacity is converted into one partition. And this is given a drive D. The other two doesn't have any label as such. So these volumes doesn't have any names. Okay, so this is what we will see today in this class. Then as we were talking about the Linux system, so Linux uses different types of partitions for different directories to minimize the impact of a file system corruption. Now, whenever you are a very novice user, if you are, then you normally say install Linux, and in the Linux or basically Ubuntu, whatever version you are using, you normally use one disk, and that disk is given for everything. So there is a root directory and then everything is given. But if you are a master or if you know that you have different disks, so what you can do, you can create or you can give one disk, say for the root of file system, one more disk or say other disk for the user activities, other disk for backup activities, other disk for other say similar functions or the variables or other programs which will be loaded. So you can have different volumes given for different directories in a Linux operating system. We will see later on when we will talk about Linux OS in general. So this is an example. So unfortunately in my system this is not the scenario. In fact, not the scenario, but in several systems you normally usually find this sort of scenario. So in fact, even if I want, I can divide this drive, say D drive, which is of say 931 GB into 2 or 3 partitions, and then it may look like this. So partition 1, partition 2, partition 3. Now the question is, when we create partition, then obviously this partition information has to be stored somewhere. And normally this partition information is stored as a table. So we have a table at the beginning ending sector, or the data and entry will have starting sector, this is in any, whenever we start a partition, basically we have a table. And this table says or talks about the starting address of the partition, ending address of the partition, and what is the file type in that particular partition. So there are these three types of entry. And if somehow partition entry is corrupted, so obviously the data will be there again, but probably you won't be able to find out the proper, say, starting and ending location of the partition, and hence you will not be able to reorganize the total content on that particular disk. So that occurs normally whenever you have a might be some sort of physical damage, some portion of the disk are erased, or someone has deliberately done that, or some virus, there is a virus malware attack, and the malware has erased that file system and so on. So that's why you need to have a good understanding exactly where this information is kept, where to start, how to start, when to start. So if you know the basic idea, probably you will try to, or you can reconstruct that portion. So I told in a Linux system, so this is how it goes on. So we had hard disk partition. So we have a volume 1. So we have one disk, we have another disk. So we have two partitions here. So C volume here, and then these two partitions together, we have OS loaded on that. We also talked about last day, we talked about sector addressing, how to address a disk. So last day we talked about that there are one way, the earlier technique was CHS. So there we had cylinder, head, and sector address. But the disadvantage or basically the limitation of CHS format is CHS can address only 8 GB of 8 GB. Hence, in later version, people started to use a logical volume address, LBS, LBA basically. So in LBA, in fact, every disk or every sector starts with 0 and it goes on, so till the larger volumes. So there are some, again, these are the practical things which you can discuss. I think I can download in this book itself. These links are given, so you can try and download this disk1.dd from the net, and then you can use this sort of tools like how to find out that say the where are the partition, what partition, like in this case if you see. So there is a tool called MMLS. So in MMLS tool, if we give say MMLS plus D DOS and disk1.dd, so it shows you that how many partitions are there, and you can see here this is the starting address, this is the ending address, this is the length of the partition, and this is the description. So you can see that this is the table entry, then we have some unallocated space, then Windows 95 or FAT32 file system, then some unallocated space, then another OpenBSD, that means Unix file system, then we have NTFS file system. And if you just see the starting and ending addresses like 1 to 62 here, then 63 to 159, then 159 to 1, then 400 to 29, and then 30 to 49. So there is no space in between, only some unallocated spaces here. So logically, if you see now this area and this area, if you see, like if I see in Windows, then you might have noticed that in C we have lot of unallocated or space which is used for other purpose we have seen here, but that is not visible to a normal user, and that's where a person who is trying to hide something can use these spaces. इस स्पेस में तो हम लिख ही सकते हैं कुछ भी ना. Am I clear?
Yes, sir.
जैसे कुछ डिस्क बेस पार्टीशन हुए हैं, कुछ अनलोकेटेड पार्टीशन है, अनलोकेटेड पार्टीशन है, इसका ये मतलब नहीं फॉर्मेटेड नहीं है, यहाँ पे लिख नहीं सकते हैं. People can write here also. So as an analysis, basically as an analyst, your job, you will not be too much, obviously you will be interested in this one कि क्या लिखा हुआ है उसने नॉर्मल डे टू डे एक्टिविटी में क्या किया है, वो हम लेटर हाफ, इस कोर्स के लेटर हाफ में पढ़ेंगे आफ्टर मिड टर्म प्रॉब्ली. So before midterm, we are also interested in कि ऐसे भी क्या कुछ जगह हैं, is there some places which is unallocated or which is normally not visible to human eye, then that may be an option जहाँ पे लोगों ने छुपा के रखा हो. जैसे this is the total layout. From this layout you can create this layout. ये डिस्क ऐसे दिख रहा है 0 to 63. So 63, this is unallocated. So first block is unallocated, nothing is here. Then you have a FAT32 file system, probably a Windows operating system, say Windows 95 operating system installed in this case. Then again you have an unallocated space, and quite a huge unallocated space. Then we have, say, Unix operating system, might be a smaller version of Unix system is, or Unix operating system is installed in this area. Then you can have you have another NTFS file system. So might be it is just partition to keep store some files, or might be it is created, or there is another operating system, might be some newer version of operating system running into that. Then to extract the file system partitions from the disk image, we can take the starter and size of each partition and plug them into DD. So now if you want to read exactly whatever is there, so if you want, okay, even in this unallocated space, what is there, or what is there in FAT32 system, what is there in OpenBSD, because you know that the writing format of this will be different, this will be different, this will be different. So DD tool, which you have already used, see the usage. So we have used MTLS to see the status of the disk. Now we have find out the partition, And then we know that this is the layout. Then what we can do, we can give if means input image, of is output image. So that's the the if argument gives the disk image to read from, so input part, so this is the output. B is the block size to read. By default, if you do not supply anything, it will be 512. Skip if you want to skip that, okay, before starting, so you skip this part and then start from this place. And then count from where, how many counts. So now you can use, so input is disk1.dd and output you can give any name. They have given it as part 1. So for this FAT32 image, they are reading it in a file system called as part1.dd. Block size they have given as 512. And since this part is not in fact not allocated, so if we want to skip this, so they are skipping it 63, and then they are finding out the ending and giving it as a count. So ending minus starting plus 1 will give you a count. No, sorry, ending minus starting will give you a count. And similarly for others, so you can read this is as a disk image called as part 1. This is read in another disk image called part 2, and this is read in another disk image called as part 3. And now once you have this, so you can now check that basically in different types. So you know that this is FAT32, so even you can use it in a Windows system and do the analysis. You can use Linux system and do the analysis and so on. So sometimes say if there are deleted partitions, so repartition a disk or clear the partition structure so that the original structure is gone. A similar but more innocent problem is recovering a system whose partition structures have become corrupt. So in that case, analysis becomes much more difficult. But fortunately, several tools exist to help recover the partition, and this section describes how they work. So how now I hope the question is clear to you. Exactly what happens. So in one case, we had a file system, we had a partition, and then we can read the partition by using MMLS tool. In some cases, say if the partition is deleted by any means, the partition is corrupted due to say failure of some of the portions of the disks or some malware have into the disk and hence it becomes unreadable, or the user himself has deleted so that he or she may not be caught. So there are partition recovery tools, and that works by assuming that a file system was located in each partition. So the first assumption of that partition recovery tool is, okay, in every such partition, there was a file system. So even we assume that here also we have a file system, here also we have a file system. Many file systems start with a data structure that has a constant magic or signature values. So for example, a FAT file system has a value 0x55 or and 0xAA in bytes 510 and 511 of the first sector. So consider that say this is a disk. So if this is FAT32 file system, the first sector will be here, say 512 size sector. So first sector is here. The last 2 bytes of that first sector will be this one. Sorry, will be this one, 55 and AA. So 510, the first sector of last 2 bytes of first sector. Again, I am repeating last 2 bytes of the first sector. Then what you can do, you can search for, so this sort of magic numbers. So if there is 55 and AA in last 2 bytes or 2 bytes of a sector, then if you can find out this, then you can say, okay, one file system starts from this. So this is probably one partition. Am I clear?
Yes, sir.
Nikita Gupta, are you there?
Yes, sir.
हो यहीं पे
Yes, sir.
Yes. तो ये बताओ कि how to find out कि given say, let me just what I just described. Sorry. Kula. So say we have a desk,
Yes, sir.
and then the partition has been somehow corrupted. So we cannot find out कि इसमें, but यहाँ ऐसे partitions थे. इसमें 3 partition थे.
Yes, sir.
Say this is 0. Say this is 1000. Say although I should have taken this is 2000. ठीक है?
Yes.
So how to find out कि किस जगह से partition start होता है? अगर मान लो कि सब में FAT32 partition है.
Sorry, sir.
Assume that all these are FAT32 partitions. Like in my system, I can have everything in NTFS format or everything in FAT32 format. No.
Yes, sir.
Even if you install say Windows 98 or if you have Windows 7, you can have all the partitions which is NTFS or all the partitions, one partition others are FAT32. You can have. Normally जब एक floppy drive को sorry floppy बोल रहा हूँ, एक USB drive को जब format करती हो तो you give us option NTFS, FAT32, FAT64 ऐसे option देती हो ना?
Yes, sir.
Are you getting it? So say there was a partition. Say this was my pen drive, and then in this pen drive I had created 3 partitions. Now somehow it has been lost. The partition information is lost. Now the question is how to retrieve that partition information. कि क्या partition थे और कहाँ से partition शुरू हो रहे थे. That's the problem. I hope this problem is clear.
Yes, sir.
बोल सकती हो?
Yes, sir.
बोलो.
So we can allocate the lost bits in gparted. First, we delete all the files, and then we again allocate all the bits.
कैसे allocate करेंगे?
Sorry, sir.
How to allocate?
So with gparted, we can allocate all the lost bits.
अगर मान लो मैनुअली करना होता तो you can see here, that's what I was discussing, or how gpart is working basically. So what you can do, you can start from say this number of this say 0 to the addressing will start from 0.
Yes,
so you
sir.
see this is 0. So the first sector will have a length of 512 bytes. So the first sector will end at 511. Am I okay? Correct?
Yes.
Normally the sector length is past 512, I assume. Then पहला sector जो होगा, it will start at 0 and it will end at 511. And as I told कि if ये अगर FAT file system है, FAT32 है अगर, तो ये 511, 510 ये जो लास्ट 2 बाइट्स है ना, यहाँ पे ये लिखा रहता है 55 और AA. ये अगर मिला फर्स्ट सेक्टर के लास्ट 2 बाइट पे, अगर ये मिला, इसका मतलब है कि हम जहां पे हैं वहां पे प्रॉब्ली एक फैट फाइल सिस्टम था. गॉट इट? ये समझ में आया? हाँ ना, तुम्हारी आवाज नहीं आ रही है.
So am I audible?
Yes, now you are audible. Is it okay now?
Yes, sir.
So similarly now you can move ahead. तुम यही चीज रिपीट करते जाओ हर सेक्टर में. May be a slow process. But you think भी नहीं होता, लेकिन कंटेंट तो लॉस्ट नहीं हुआ है, सिर्फ फाइल टेबल पार्टीशन टेबल लॉस्ट हुआ है या किसी ने जानबूझ कर लॉस्ट कर दिया है. तो इफ यू कंटिन्यू, अगर फैट फाइल सिस्टम है जहां 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 से शुरू हो रहा है, मान लो जैसे यहाँ एक शुरू हो रहा है, तो फिर यहाँ पे इसको अगर तुम रिलेटिवली 0 मान लो, तो इसके रिलेटिव में जो 510 511 और 510 और 511 आएगा, वहां पे भी इस तरह का नंबर मिलेगा. सिमिलर सिनेरियो विल occur here also. Then by that you can say कि सर यहाँ से एक पार्टीशन स्टार्ट हुआ था, यहाँ से एक पार्टीशन स्टार्ट हुआ था, और यहाँ से एक पार्टीशन स्टार्ट हुआ था. क्योंकि यहाँ से एक स्टार्ट हो रहा है, तो दिस पार्टीशन शुड ऑब्वियसली एंड हियर एट मोस्ट. इसके पहले सिमिलरली दिस पार्टीशन स्टार्टिंग फ्रॉम दिस प्लेस, बट इट शुड एंड एट मोस्ट हियर, या इसके पहले खत्म होगा. होगा ना. So that's what it is saying here. So has a value this. So the partition recovery tool search for this signature values and identify where a partition may have started. So when the search tool finds a signature, additional tests can be conducted on the range of values that has values for a given data structure. So for example, a fact file system has a field that identifies how many sectors are in a cluster. It must be a value of a power of 2. Okay. And the search mechanism of every tool may vary. Some in each sector and compare with. So this is where in fact if you want to do research, अगर मान लो कि हम रिसर्च की बात करें, दो तरह की चीजें हो सकती है ना, कि हम तुम एक सिर्फ यूजर बनना चाहते हो जो फॉरेंसिक में एक्सपर्ट होना चाहते हो. That means you want to an expert who can find out this partition. So you need to be mastery, get a mastery in this sort of tools. You need to explore all the possible tools. On the other hand, if you say, no, sir, I want to do research, I'm not interested in using these tools, but I'm more interested in developing this sort of tools. You can think of, okay, how to restore this. That can be a very good research area. Right. So these are the tools. Again, we'll see in lab classes. I'm not going to discuss this G part and so on in this theory class as such, but in lab classes, obviously. Now, since this book is with you, the tools are already, references are given, and he has also given all the data, etc. A good reference to that. So go this. And this book is in fact one of the, you can say, best book available on disk analysis. So far whatever I have searched, so my finding is this is by far the best book, best acclaimed and say appreciated books by every corner of the world. Okay. So next we will move on to the DOS partitions. So in DOS partition, in fact, if we talk about the DOS partition, because that's where mostly we work. So in DOS partition, in DOS partitions have been used with IA32 hardware, that is Intel i36 to x86 architecture for years. And there are many Microsoft and non-Microsoft documents to discuss the partitions, but there is, as such, there is no standard reference. In DOS partitions, what we are going to talk about is basically the master boot record disk. So there are no standard as I told. So Microsoft now calls disks using this type of partition system master boot record, MBR. So we are now going to discuss about the MBR disk, how MBR disks in a DOS based or PC based system works. So in basic MBR disks, a disk that is organized using DOS partition has an MBR in the first 512 byte sector. The MBR contains boot code, a partition table, a signature value. The boot code contains the instruction that tell the computer how to process the partition table and locate the operating system. The partition table has 4 entries, and each of which can describe a DOS partition. Let's see that. So now we have seen, like as I told this in this one. So if say this is a FAT based partition. So this is say 512. Then next will be 1023 and so on. This will go on. This is a FAT file system, FAT based MBR record. So this is sector 1. I hope इतने दिन से डिस्कस कर रहे हैं ये तो सबको कम से कम पता हो कि this is one sector. By default we are assuming that sector length is 512 bytes. So पहला sector है ये. This is the first sector and that's what it is saying that a disk that is organized using dot has MBR in the first 512 byte sector. अगर इस पूरे पार्टीशन में इतने सारे सेक्टर्स हैं, जैसे मान लो कि इसमें 1023 प्लस 512 जोड़ दो, अगर इतने सारे सेक्टर्स हैं, ये एक ही पार्टीशन है. दिस इज अ सिंगल पार्टीशन से. ये एक पार्टीशन है, एक सिंगल पार्टीशन है. तो एक सिंगल पार्टीशन में बहुत सारे इस तरह से सेक्टर्स होंगे. सेक्टर 0, सेक्टर 1, सेक्टर 2, 3, 4. अगर 1 से ले तो 1, 2, 3, 4. So first sector and each sector is 512 bytes. So in first sector we have MBR record. What this MBR contain? So इसके पहले पार्ट में इस सेक्टर के, so in this part in fact you have these informations basically. क्या क्या इंफॉर्मेशन है? You can see starting CHS address, ending CHS address, starting LB address, number of sectors in the partition, number of partition and flags. Sorry, type of partition and flag. So यहाँ पे क्या क्या रखेगा? पहला रख रहा है कि CHS starting address, दूसरा CHS ending address, तीसरा LBA. Now you can see here both the supports are given in DOS-based system. CHS support as well as LBA support. Most of the any one of them will be on. अगर CHS यूज करेंगे तो हम जानते हैं कि हम 8 GB से ज्यादा बड़े डिस्क का यूज नहीं कर सकते. So this partition is not going to be bigger than 8 GB. But there is no limitation on LBA. So newer system have mostly using LBA. So in that case CHS will be 0. So they will be not using. Then next thing was number of sectors in the partition. So number of sectors, and this is a flag, type of partition, and then a flag. Okay, so पहले सेक्टर के पहले पार्ट में ये इंफॉर्मेशन लिखा हुआ होगा. क्या क्या होगा? If it is on, otherwise LB address. कुछ केसेस में हो सकता है कि दोनों ही हो. That depends on the application or that depends on the operating system. So, but most of the time, any one of them will be on either CHS or LBA. In newer disk, it is more common to find LBA instead of CHS. Then we have number of partition, number of sectors. Number of sectors in the partition. So if you are using LBA addressing and then you have number of sectors, then you can say the size of that total partition. Next is type of partition. ये partition किस type का है? Is it FAT? Is it NTFS? FAT में भी बहुत तरह का है. Is it say EX32 or EXT2? Is it FreeBSD and so on? किस तरह का है? And this flag designates कि whether it is a primary partition and bootable code is there, or is it not that. So these are the informations which are kept. So you can see here there is a diagram also. I think there was a diagram. So this is the diagram. Oh, no, there was a diagram. Okay, so there is no diagram. I think I missed it. So you can see here the description is given here. Each table describes the layout of a partition in CHS and LBA address. CHS address only for disk less than 8 GB size, but LBA address may allow disk up to terabyte. The type field in partition identifies what type of data should exist in the partition. Common example include FAT, NTFS, FreeBSD. The next section has a component partition type. So this is, and then each entry also contains a flag field that identifies which partition is bootable one. So if this partition is, if the partition we are talking about, if this is bootable one, then this flag will be 1. If this is not bootable, then flag will be 0. Okay. So you can see here one partition is shown here. So in fact, 2 partitions are shown here. So there are 2 partitions in this one, and now you can see that there is a table here. And in this table we will have, in this table we have something like this. Okay. Then there is extended partition concept. So MBR is a simple method of describing up to 4 partitions. So you can see here inside of there will not see a file system for. So this is MBR is a simple method of describing up to 4 partitions. However, many systems require more partitions than that. For example, consider you have a 12 GB of hard disk and you want to divide them into 6 partitions. Okay, and multiple OS, or you want to use your disk in that way. So you cannot describe the 6 partition by using the 4 partition table entries, which is shown here. Okay, I think this book is missing something. Some portions are not there in this one. Which was there in the hard copy. So actually an MBR is a way by which we can describe up to 4 partitions. However, if we want to make more than 4, the solution is given something like this. So the solution is the basic solution is to use 1, 2 or 3 type of the entries in the MBR for normal partitions. So since you know that every partition table entry in MBR record can use only 4 partitions, so what normally is done is we create, say, maximum 3 partitions we can directly create, and then 4th one will point to one extended partition. So you might have seen that in Windows, when you create another partition, that gives extended partition. So after 3, like if in this disk, what I was just showing you, so if I try to create one more partition in this one, in SATA disk, already there are 3 partitions. So 4th partition will be obviously an extended partition. And in this extended partition again, so you can assume that, okay, 3 partitions, so I have a place for keeping partition information, 3 partition informations. And in each partition information, so each block here, see here, each block here, each entry here will contain these informations. Okay, and there are as such 4 fields. So 4, this entry, you can consider this entry together to be this area. So this area. So for partition 1, you have these entries. Again, partition 2, you will have these entries, which will be written in say, this block 2. Then for partition 3, you will have the same entry. Obviously, the values will change here. And then for 4th, you can have. So if you have 4 only, you can go ahead. So even for 4th also, we normally go for extended instead of just going through directly. So now if we create, so here we make an extended partition, and then in extended partition, I can again partition it into 4. So you can see here. So like secondary extended 1, then secondary file system, and secondary extended 2, then secondary extended 2. So this will give you one more partition way of, one more way of doing the partition. I think a bigger figure is shown here. No. Figure 5.4. Somehow figures are missing. As I told, no, some portion of these books are missing. hard copy you can find out these figures. Oh, so far is it okay?
Yes, sir.
Yes, yes, sir.
Okay, so now let's see exactly one example. So another one is, as I call, boot code, like when the system operates. So the boot code in the DOS disk exists in the first 44.6 byte first 446 bytes of the first 12 byte sector, which is the MBR. So as I was talking, this is a disk that in first 446 bytes, you will have the boot code. So that boot code will tell exactly how to switch on the system. The end of sector contains the partition table. The standard Microsoft boot code processes the partition table in MBR and identifies which partition has the bootable flag set. When it finds such a partition, it looks in the first sector of the partition and executes the code found there. The code in the start of the partition will be operating system specific. Boot sector viruses insert themselves into first 446 bytes of the MBR, so they are executed every time the computer is booted. Again, now you can think of those malware concepts we talked about. So if you want to make your malware uh, being on every time or execute, take control of them, one or the other way can be they can put their values into boot sector directly. So if somehow they can get inserted into first 46 bytes of the MBR, they will be executed every time the computer will be booted up. So it is becoming more common to have multiple operating systems on a computer. There are two ways to handle this. Windows handle this by having code in the bootable partition that allows the user to select which OS to load. So if you have more than one OS running on the system, you can write one line in that bootable code itself that will give you an option if there are more OSs, which one to select. So the boot code in the MBR execute first and loads the Windows bootable code. The Windows bootable code allows the user to choose a different partitions from which to boot. The other method is to change the code in the MBR. So the new MBR code represents the user with a list of options. So there is nothing to be booted. So that will just give you the list of options. And the user chooses which partition to boot from, and typically requires more code and uses more of the unused sectors and some of the unused sectors that exist before the partition starts. Now, this is how the whole, if I say on a Windows system or in a DOS-based legacy system, how the partitioning was done. So just if we just summarize everything. So in a DOS, we have two ways. In fact, one is MBR, the other newer one is called as GPT partitions. Yes, that they are called as GPT now. So we are here we are talking about the MBR or the legacy one. So in MBR, every partition, at the start of every partition, in fact, we have starting CHS address, ending CHS address, starting LB address, number of sectors in partition, type of partition, and flag. And it can support, or it supports only 4 partitions. A normal MBR supports only 4 partitions, and they are written in this way. So we have a disk, and then at the start of the disk, we have say 4 entries, and each entry will have this. So you can see 4 structures. So it's a structure. So this structure will be placed here. So it can point to 4 different types of partition. If you want to have 4 or more than 4, then normally we go for extended one. So 3 partitions we keep here directly, and for 4th we get an extended partition. And again, inside that extended partition, we create a similar structure of 4. So again, we can, if you want to go more, then you can have 3 here from the extension and then further extended. And that way you can continue going on. And then this last part where we have a flag, then this flag says, okay, this partition is bootable. So you will find your OS code here. So in that partition, the first 446 bytes of that sector 1 normally contains the boot code. if you have one OS, you have the boot code and you can execute your system. If you have multiple OSs, then there are two options. In the boot code, you can, so you start with the boot code, and then there is a line which will ask which OS you want to run. And then probably you can select and it can start, it can just start loading. The second option, we do not have any boot code there. We have just an option. You can, these are the OSs. So which OS you want to run. So basically you select there which partition you want to run, and the user itself selects the partition, and then that goes to the partition and it runs that from that particular place. Now, in order to maintain all these things, you need to, these things has to be stored in are basically to be maintained by data structures. So now if we think of the MBR data structures, so in MBR data structures, as we talked about, so we talked about that there will be 4 table entry, partition table entry. So first 5, in fact, this is the complete data of the first sector, you can see. Okay. This is the data of the first sector. So we talked about now. So this is a first sector. So the complete, what is there in the total first sector. So that's the thing. So first 446 entries are boot code. Then we have 446 to 461, the partition table entry. And this partition table entry is this one. This one. This is what we mean by partition table entry, as I told, so this one. Then the second partition table entry, then third partition table entry, fourth partition table entry, because there can be 4. And then magic numbers, as I told, if it is a FAT32 or DOS-based partition, then at the 511th, 510th and 511th, we will have that magic number AA and 55. And now inside the DOS partition entries, so each entry, so each partition table, in fact, it was already given. So this was, so sorry, each partition table entry, I told that these are the things. So now these things in terms of byte, how many byte they take, this is this one. So byte, 0th byte basically are 1 byte, we have a bootable flag. Then we have 4 bytes for start address. 1, 2, 3. 2 bytes, and then we have then partition type of 1 byte, then ending CHS address again of 2 byte, and then 4 byte for LB address, and then we have 4 byte for size in sector. Is it okay?
Yes, sir.
Yes, sir.
बोलो मनोज, क्या समझ में आया?
सर बूट रिकॉर्ड समझ में, MBR समझ में आया सर.
MBR समझ में आया?
Yes, sir. Yes, sir.
Good. चलो अब तुमको नंबर दिया जा रहा है. So say we D3. See this one, this example. So अभी हम कमांड नहीं देख रहे हैं. We are just seeing this one. जो highlighted portion है उसको देखो.
Yes, sir.
This is one sector. ये एक सेक्टर का लेखा जोखा है. फर्स्ट सेक्टर का, एक पार्टीशन के फर्स्ट सेक्टर का. जैसे अगर हम पढ़ेंगे, सुनो सभी लोग ठीक से सोचो कि एज आई टोल्ड कि फर्स्ट सेक्टर में क्या होगा. एक 512 एक सेक्टर का साइज 512 बाइट है. नाउ इनसाइड दैट 512 बाइट्स, as we discussed, as it is written here, कि पहला 446 बाइट्स तक क्या होगा, बूटेबल कोड होगा. तो इसका मतलब है कि यहाँ तक जो भी बूटेबल कोड है. Am I clear? एग्री करते हो तुम लोग? This is the address. ये पोर्शन जहां माउस है वो एड्रेस है. अचला कुमारी.
Yes, sir.
Do you agree with me? जो मैंने सेट किया है वो बूटेबल कोड है। ऑपरेटिंग सिस्टम
Yes,
कैसे कैसे बूट करेगा, हाँ या ना?
yes, sir.
Yes. So you agree with that? So because these are the addresses 384. So ये देखो 334 432 है, 432 435 436 437 438 439 440 441 442 3 4 5 6 ये गलती किया जी मैंने। 32 3 4 5 6 7 8 9 10 then 1 2 3 4 5 6 क्या गलती कर रहा हूं मैं? 1 2 3 4 5 6 7 8 16 32 16 गलती कहाँ कर रहा हूँ? 33 34 35 36 37 38 39 40 41 42 43 44 45 46 47 48 ओहो सॉरी
सर
32
हेक्साडेसिमल
will be
में
here.
सर ये सर
Right.
हेक्साडेसिमल में
So
सर
thank
दो
you.
बिट रहेंगे।
नहीं दो ही होगा, ये 32 ये होगा एक्चुअली 32 जो लिख रहा है, सो दिस इज 32। आई वाज टेकिंग इट फ्रॉम 33। ये 32 होगा ना, ये तो जस्ट लेवल है।
यस
32 एड्रेस नंबर 432 विल बी, जो मैंने हाईलाइट किया वो होगा।
यस
ठीक है सभी को?
यस
यस सर।
सही है ना? तो नाउ इट विल बी 32 33 34 35 36 37 38 39 40 41 42 43 44 45 46 47. So these are 46 47. ठीक है? Then next will be 48. Clear?
यस सर।
अब देखो 46। अब अगर इसको हम लोग देखें तो अप टू 445 तो बूट कोड था। सो यहाँ तक बूट कोड था, ये क्लियर है। यहाँ तक बूट कोड था, इसको हम छोड़ देते हैं, इससे हमको कोई मतलब नहीं है अभी। नेक्स्ट वाज 446 से 461 तक पार्टीशन टेबल एंट्री 1 था। तो कि यहाँ से लेके यहाँ तक इनफैक्ट ये पूरा एरिया ये पार्टीशन टेबल एंट्री 1 के लिए होगा। 4 पार्टीशन होते हैं, हम लोग जानते हैं। तो पार्टीशन टेबल एंट्री 1 will be this one. अब पार्टीशन टेबल एंट्री 1 अगर है वो, तो उसके अंदर में इतने फील्ड होंगे। फिर ये भी सही है?
यस सर।
तो पहला पार्ट है बूटेबल फ्लैग। सो देखो 446 जीरो है, यानी कि ये बूटेबल नहीं है। क्या?
फ्लैग सर।
आई थिंक कोई कुछ बोल रहा था, बोलो। someone was saying something.
सर ये 001 जो है ये सर 446 है ना सर?
446 is the address. In fact, this
Yes,
is
sir.
the address है, और यहाँ तो एक एक बाइट है, सॉरी दो बाइट है।
दो बाइट है सर।
और एड्रेस हम लोग दो बाइट है। नहीं सॉरी, ये दो मिला के एक बाइट हुआ ना। मैंने ये एक्चुअली 16 बिट का ये एड्रेसिंग मैकेनिज्म है। सो इन दोनों बाइट्स के लिए एक एड्रेस है, ये 2 बाइट के लिए एक एड्रेस है। वर्ड एड्रेसेबल कंप्यूटर है, ये बाइट एड्रेसेबल नहीं है। तो मैं क्लियर, 16 बीट के एड्रेसेस है और उस 16 बीट को हम लोग एड्रेस कर रहे हैं। 2 बाइट को एक साथ एड्रेस हो रहा है इस सिस्टम में, जो भी है।
यस
क्या
Yes,
जो मुझे समझ में आ रहा है, देखो
Yes, sir.
दिस इज व्हाट यू
वही
नीड
है।
टू सिंपली अंडरस्टैंड। क्योंकि देखो ये जो है तुम्हारा 384 है, तो यहाँ से यहाँ तक पूरे एड्रेस का गैप कितना है? 16 बिट का है।
Yes, sir, 16
16 है। सो 16 के अंदर में तुम कितने वैल्यू एज सच, अगर तुम बाइट्स देखो तो 4 बाइट्स करके तुम 64 बाइट्स को ये कर रहे हो। इनफैक्ट टोटल 3 4 5 6 7 8 सॉरी 32 बाइट्स को कर रहे हो। इसका मतलब क्या कि 2 बाइट मिला के एक एड्रेस हो रहा है।
Yes.
तो ये टुगेदर इज एड्रेस। सो दिस 00 इज प्लेस्ड एट द एड्रेस 384. So here this 00 will be placed at the address 446. Address number 446 will contain 00. Let us just take this paint window. इतना में हम लोग कर सकते हैं। यहाँ से देखो, अब हम लोग अगर यहाँ से वैल्यू लिखना शुरू करें तो हमारा एड्रेस नंबर 446, then 4 4 7 8 9 4 5 0 1 2 3 4 5 6 7 8 60 61 2 3। ठीक है, तो 446 पे क्या होगा? कंटेंट
00
447 पे कंटेंट होगा 1, 48 पे भी होगा 01, 49 पे होगा अगेन 00, 50 पे होगा 07, फिर FE,
3F,
फिर 3F, फिर 7F, फिर से 3F, फिर 00 00 00 00 00 41 60 1F 00 80 सॉरी मैंने क्या लिख दिया, दिस इज 1F।
सर 7 पे 8 पे सर 41 होगा ना सर?
हाँ गलती लिख दिया मैंने।
यस सर, ये 3F के बाद सर
3F के बाद 00,
यस सर,
फिर
उसके बाद
00,
फिर 00,
फिर
फिर 00,
00।
लेकिन सर आपने उसके बाद फिर एक 00 गलती से।
हाँ 4 पे 3F हुआ, ठीक है, देन 00, देन 00, देन 00, देन 41 सॉरी, then 41, then 60, then 1F, then 00। ठीक है, उसका तो ये फिर 80 और फिर ये 00। इसकी जरूरत नहीं, हम लोगों को इतना ही तक देखना है। इनफैक्ट ये फिर दूसरे का पार्ट हो जाएगा। 16 हो गया ना, 1 2 3 4 5 6
Yes, sir, 16
15 16, 18 कैसे हो गया? ये भी लगता है नहीं आएगा। अब देखो क्या है जो यहाँ बोल रहा है, जो वैल्यूज थी देखो, इट वाज कि पहला जो 00 होगा वो बूटेबल वैल्यू दिखाएगा। सो पहला बाइट जो है वो, पहला 0th बाइट जो है वो बताएगा कि ये बूटेबल है कि नहीं। तो ये 00 है, इसका मतलब है कि ये बूटेबल डिस्क नहीं है, राइट? ये ना कि पहला पोजीशन का जो बाइट होगा वो बताएगा कि ये बूटेबल है या नहीं है। इसका वैल्यू अगर 00 है तो इसका मतलब है कि ये बूटेबल नहीं है।
यस सर।
देन नेक्स्ट है कि स्टार्टिंग CHS एड्रेस। सो 1 2 3, ये 3 बाइट मिला के CHS एड्रेस देंगे। 1 2 3, 1 2 3, ये मिला के CHS एड्रेस देंगे। इसकी हमको अभी जरूरत है नहीं। देन नेक्स्ट जो है हमारा पार्टीशन टेबल देगा। अब पार्टीशन टेबल, इसका मतलब है कि वो किस तरह का पार्टीशन है, व्हाट टाइप ऑफ पार्टीशन इट इज। इसका वैल्यू 07 है। यहाँ एक वैल्यू दिया हुआ है देखो, कि अगर यहाँ वैल्यू 00 आए तो इसका मतलब है कि वो कोई पार्टीशन नहीं है, एम्प्टी है। अगर ये 01 होता तो फैट 32 होता और उसमें CHS वैल्यूज आते। यहाँ पे देखो 07 है, इसका मतलब है कि ये NTFS है। तो ये पार्टीशन क्या हो गया, NTFS। टाइप 4th बिट क्या हो गया, NTFS। ठीक है। फिर 5th 6th 7th, ये 3 जो है वो फिर CHS के लिए है। इसकी हमको जरूरत फिलहाल नहीं है क्योंकि NTFS के साथ CHS काम नहीं करेगा, सो वी इग्नोर इट। देन 8th 9th 10 11, ये स्टार्टिंग LBA एड्रेस है। नाउ इस LBA एड्रेस में चूंकि अब मशीन का वो इंडियननेस देखना होता है, ये मशीन नॉर्मली क्या है कि आई थिंक दिस इज लिटिल इंडियन मशीन। सो लिटिल इंडियन मशीन है, इसलिए इसका उल्टा कर लेंगे हम लोग नॉर्मली। तो ये हो जाएगा 0 0 0 3F। ये आई थिंक लास्ट टाइम मैंने पढ़ाया था सबको कि क्या होगा। हम लोग इस एरिया से पढ़ना शुरू करेंगे, लिटिल इंडियन है इसलिए। राइट तो ये 30F, ये हो गया स्टार्टिंग सेक्टर, सॉरी 3F। अब 3F का वैल्यू डेसिमल में अगर देखोगे तो ये 63 है। यानी कि ये जो पहला इसका पार्टीशन शुरू हो रहा है, पहला पार्टीशन जो होगा वो किस एड्रेस से शुरू होगा, 3F से शुरू होगा। ये इनफैक्ट इसी यही फिगर है देखो, ये वाला है देखो, से शुरू होता है 32 था लेकिन वहां NTFS है, राइट। बोलोगे ये हो गया हमारा स्टार्टिंग LBA एड्रेस। उसके बाद क्या है 12 से 15, ये कितने 11 तक हुआ था, 12 13 14 15, ये है सेक्टर्स इन साइज सेक्टर्स, टोटल कितने सेक्टर्स हैं। तो अगेन ये नंबर जो होगा 1F6041, बिकॉज अगेन इंडियननेस के कारण हम लोग इसको यहाँ से इस तरफ से पढ़ना शुरू किए हैं, इसको भी हम इस तरफ से पढ़ना शुरू किए। सो इतने सेक्टर्स हैं उसमें, देखो यहाँ पे निकाल के भी दिखाया है मेरे ख्याल से कि इतने सेक्टर्स हैं, 00 1 80, सॉरी ये है साइज, ये 6041, इतने सेक्टर्स हैं उसमें टोटल। तो अब उसका साइज निकाल सकते हो तुम कि कितने साइज का ये होगा। स्टार्टिंग एड्रेस 63 है और ये टोटल साइज इतना है। सो वो कहां से कहां तक जाएगा, ठीक है। उसी तरह से तुम अगर फिर दूसरा एंट्री लो, फिर यहां से अगर शुरू करो तो अब देखो क्या है कि पहला बिट जो है वो 80 होगा, फिर 00 होगा। ना अगर 8 0 है तो हो सकता है कि 8 0 का वैल्यू क्या है, बूटेबल है। बिकॉज देन दिस फील्ड विल बी 8 0। 8 0 पे शायद बूटेबल हो। यहाँ कुछ लिखा है क्या? यहाँ लिखा नहीं है, बट देखना होगा कि 8 0 in bootable. The second entry is set to bootable. 8 0 मतलब bootable है। तो इसका मतलब है कि अब जब देखोगे सेकेंड एंट्री के लिए जब शुरू करोगे तो ये वैल्यू इंस्टेड ऑफ 0 0 आएगा क्या, 8 0। यहाँ से 8 0 आएगा ना, तो इसका मतलब है ये बूटेबल हो गया। फिर देखोगे तो ये 0 0 हो गया, ये वाला पोर्शन, ये 0 1 8 0। फिर नेक्स्ट जो है वो 83 है। तो अब तुम्हारा ये यहाँ जो हम लोग ले रहे थे 0 7 07 हमको था कि NTFS फाइल सिस्टम है, अभी मेरा उसके जगह 83 है। सो यू कैन चेक अगेन कि 83 में क्या होता है। तो ऊपर था 83 इज लाइनक्स ऑपरेटिंग सिस्टम। सो वो जो पार्टीशन है वो लाइनक्स का हो जाएगा। सो बोलोगे कि जो सेकेंड पार्टीशन है वो लाइनक्स के लिए है, 83 है। उसके बाद अगेन 3 बिट मिस करोगे, फिर यहाँ से शुरू होगा तो ये उसका स्टार्टिंग एड्रेस, उसका एंडिंग एड्रेस। फिर उसके नेक्स्ट वाला देखोगे तो नेक्स्ट वाला फिर से 0 0 है, बूटेबल नहीं है। फिर उसके बाद इसके नीचे वाला 83 है तो वो भी लिनक्स पार्टीशन है, और फिर उसका बाकी इंफॉर्मेशन। फिर उसके नीचे वाला देखोगे तो वो भी बूटेबल नहीं है, लेकिन फिर उसके बाद जो फाइल सिस्टम है वो 05 है। तो 05 क्या होगा, तो यहाँ वो माइक्रोसॉफ्ट एक्सटेंडेड CHS है। सो माइक्रोसॉफ्ट एक्सटेंडेड पार्टीशन है और वो CHS यूज कर रहा है। तो इसका मतलब क्या होगा कि ये वाला पोर्शन भी हम पढ़ेंगे तब, और ये वाला भी पोर्शन पढ़ेंगे CHS एड्रेसिंग के लिए। वो एक छोटा पार्टीशन है जो ऑब्वियस है कि 8 GB से छोटा है। और इसका लास्ट बाइट देखो 510 और 11, एक काउंट करोगे यहाँ से तो 96 96 97 98 99 100 500 500 1 2 3 4 5 6 7 8 9 10 11। तो 510 एंड 11 क्या है देखो, 55 और AA। सो 55 और AA एक साथ इस पूरे को पढ़ोगे तो AA 50 इंडियननेस के, इंडियन ऑर्डरिंग, इंडियननेस के कारण एंट्री उल्टा है। सो 55 AA बेसिकली ये लिखा हुआ है AA 55। सो सिंस इट इज AA 55, सो दैट डेजिग्नेट्स कि ये क्या है, ये एक फैट फाइल सिस्टम का पहला पार्टीशन है, मतलब यहाँ से एक पार्टीशन शुरू हो रहा है, ये पहला सेक्टर है किसी एक पार्टीशन का। ठीक है, देखो इस किताब में ढूंढो, ये डिस्क 3 का लिंक वगैरह आई थिंक चैप्टर एंड में शायद दिया हुआ है। लेट मी जस्ट go to that. Scope of the book. ये देख लो, यहाँ पे जा सकते हो तुम, और बहुत सारे यहाँ पे, ये यहाँ पे देखो यही बुक है, ये सेल्यूथ किट भी है, एंड देन टूल टेस्टिंग। सो देखो यहाँ पे है एक्सटेंडेड पार्टीशन टेस्ट, यू कैन डाउनलोड दिस, ये इमेज डाउनलोड कर सकते हो। ठीक है, 150 MB से 160 MB के आसपास है, ये डाउनलोड कर सकते हो। और यहाँ पे जो अभी हम लोग आज डिस्कस किए कि प्राइमरी टेबल एक्सटेंडेड टेबल कहाँ से, यहाँ पे ये भी दिया हुआ है, डिस्कशंस भी दिया हुआ है कि MS-DOS पार्टीशन को हम लोग कैसे करेंगे। सो माय सजेशन विल बी कि डाउनलोड ऑल दिस शेयर, कि हम जो भी यहाँ पे दिए हुए हैं कि फैट वॉल्यूम लेवल टेस्ट कहाँ से कहाँ तक है, कैसे है, नहीं करेंगे। सो ये लैब असाइनमेंट के लिए तुम लोग का लैब असाइनमेंट है, यहाँ से निकालो और इसको टेस्ट करके बताओ। इस वेबसाइट को देखते रहो, यहाँ और भी बहुत सारा चीज मिल जाएगा तुमको, चैप्टर्स भी है, ये तुम्हारे कुछ ये और बहुत सारे ओपन सोर्स फॉरेंसिक के टूल्स भी अवेलेबल है यहाँ पे। क्या खोल रहा है? This is वेबसाइट नहीं है।
सर होस्टिंग एक्सपायर हो गया ना, तो वो पार्क कर दिया।
यहाँ पे बहुत सारे पेपर्स हैं। इसका पीएचडी डिसर्टेशन है कैरियर का, देखो 2006 में किया है खुद का। उसके बहुत सारे पेपर्स हैं। सो ये अदर देन दैट फिलहाल तो तुम ये जो टेस्टिंग टूल्स हैं इसको तो डाउनलोड कर ही सकते हो, दे आर फ्री डाउनलोडेबल। इसको डाउनलोड करो और लैब क्लासेस में हम लोग नेक्स्ट डे ये जो भी आज सीखे हम लोग कि कैसे हम लोग क्या क्या है इसमें, और क्वेश्चंस वगैरह इस तरह के क्वेश्चंस भी रहेंगे भाई। बाद में नहीं बोलोगे कि आई मे गिव यू, मान लो कि हम मेरे पास कोई दूसरा ये से मैं निकालूंगा और आई कैन गिव यू दिस सॉर्ट ऑफ नंबर्स एंड आई मे आस्क यू कि भाई इस तरह से तुम निकालो कि उसमें कितने पार्टीशन है, कौन सा पार्टीशन किस तरह स्टार्ट हो रहा है, कहाँ है। यू मे एक्सपेक्ट इन योर मिड टर्म एग्जाम। तुम्हारा मिड टर्म एग्जाम है कब से?
8 मार्च।
28th of March, sir.
28th of March. So that by that time you will be here only, और एग्जाम्स फिजिकल ही होंगे, so that's for sure. So अच्छे तरह से पढ़ो, बहुत ज़्यादा कंटेंट वैसे बहुत ज़्यादा नहीं है, सिंपल है, और इसको प्रैक्टिकली देखो, ठीक है। So today we will stop here, go through this book. पहला पोर्शन मिड टर्म तक तो यहीं से रहेगा, उसके बाद दूसरे पोर्शन पे हम लोग दूसरे तरह के जैसे नेटवर्क फॉरेंसिक, ईमेल फॉरेंसिक बदलेंगे, बट अभी तो यही रहेगा कंटेंट इसी बुक से। राइट, एनी अदर क्वेश्चन? ऑलरेडी ये शेयर कर दिया, किताबें शेयर कर। हाँ बोलो, कुछ बोल रहे थे कोई? Okay then, see you tomorrow. Okay.
Thank you, sir.
Okay, thank you, sir.
Thank you.